the sort, the bane of many a programmer and web developer's existence, and yet a vital tool for any programmer or web developer's skill set. Today we are going to be going through katas that involve a lot of sorting, from circular arrays to drinking water to strings and ranking numbers. Hello world, and this is Versus Codewars. We begin today with the warm-up segment, a series of easier katas in order to prepare for the more challenging katas later in the episode. Today's episode, we are dealing with katas that deal with sorting, and we begin today with a function that takes a sequence of numbers, an array of numbers, as the single parameter. And the goal of this kata is to sort out all of the even numbers in that array and add them together. Let's go ahead and give this a try here. Const sum even numbers, and we have our array of numbers right here. And what we'll go ahead and do with those numbers is we're going to run that through the reduce method, and we're going to have our accumulator and our number here, and we're going to set that initial accumulator to 0. Now we need to determine if this number is even, and we can do that by doing this. If the remainder of number divided by 2 is equal to 0, we'll return our accumulator plus our number. Because if the remainder of number divided by 2, or number modulo 2, as shown by this % sign here, is equal to 0, that means that this number is even here. So we'll go ahead and add that number to our accumulator. Otherwise, we'll just go ahead and return our accumulator itself. Alright, let's go ahead and punch this into Codewars and see what this looks like here. Let's go ahead and test this out here. And we are good on that. Our next warm-up kata, we have Liftoff. We have an array of numbers 1 through n, where 1 is less than or greater to n, and n is less than or greater to 10. This array needs to be formatted correctly for the person reading the countdown of a spaceship launch. Unfortunately, the person reading the countdown only knows how to read strings. After the array is sorted correctly, we have to make sure it's in a format that he can understand. Between each number should be a space, and after the final number, we should have the word liftoff. Let's go ahead and give this one a try here. As you can see here, we have an array of numbers in an unsorted order. And the string here should show those numbers in descending order, followed by the string liftoff. Let's go ahead and try this here. Const liftoff, and we'll have our countdown, we'll call it, of our numbers in our array. And what we'll go ahead and do is we're going to go ahead and return countdown.sort, and the sorting function is going to sort these numbers in descending order, so we'll do b minus a. We will then go ahead and join those numbers together with a space separator here. And then after that, we're actually going to go ahead and put this in a template string right here. And then after that, we're going to have our liftoff right here. All right, let's see if we have that right. Let's go ahead and take this array right here, and we're going to do a console.log liftoff. We're going to paste that array right in here. Let's test this out here. Node warm-up liftoff. And as you can see, we have our 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 liftoff right here. Let's go ahead and punch this into Codewars to see what this looks like here. We're going to run this hold lone test here. And we are good on that. For our next warm-up kata, we are sorting gift codes. Santa's senior gift organizer, Elf, developed a way to represent up to 26 gifts by assigning a unique alphabetical character to each gift. After each gift was assigned a character, the gift organizer elf then joined the characters to form the gift ordering code. Santa asked his organizer to order the characters in alphabetical order, but the elf fell asleep from consuming too much hot chocolate and candy canes. And our goal is to help him out by writing a function that accepts a string containing up to 26 unique alphabetical characters and returns a string containing those very same characters in alphabetical order. Let's go ahead and give this one a try here. Sort gift code, and we have our code right here. Now, what we can go ahead and do with these characters is we're going to go ahead and split this string into its individual characters here, and we're going to need to sort this in ascending order. And if I'm not mistaken, the array.sort method can do this without a sorting function. Let's see about that here. What we'll go ahead and do, we're going to go ahead and do return. We're going to do a destructuring spread right here, ... code. What this does is it splits, this spreads the characters of our string here into an array right here. We're going to take that array, we're going to do .sort. Now, when it comes to characters, if I am not mistaken, JavaScript will automatically sort these characters in ascending order, alphabetical order. We're going to take that sorted, we are going to take those sorted characters and join them back together with a blank string separator right here. Let's go ahead and play around with this right here. We're going to do console.log sort gift code. We're going to take this string of unique characters right here. And we're going to test this out here. Node warmup sort gift code. And as you can see, it looks like we do in fact have our characters sorted into alphabetical order right here. Let's go ahead and punch this into Codewars to see what this looks like here. And we're going to run the test here. And we are good on that. For our next warm-up kata, we are taking a two-dimensional array of integers, flattening them, and then sorting those integers together into ascending order. Let's go ahead and try this one here. Okay, let's do const flatten and sort. We're going to have our array as our lone parameter here. What I think we'll go ahead and do, if I'm not mistaken, the array.push accepts more than one argument. Let's have a look at that here. We're going to do a blank array.push. Yep, it seems to take more than one argument here. That is going to come in very handy here, because we are dealing with multiple subarrays in our array here. In fact, I'm going to go ahead and take this right now, and I'm going to paste this down here. Console.log flatten and sort. We're going to paste this array right here. So what we're going to go ahead and do, we need to first iterate over each of our subarrays here, and then push each of those individual elements into our result array here. And we can actually do that by doing this. Return array.reduce. We are going to have our result array here and our sub array here in our predicate function here. We are going to set the initial result to an empty array here. And what we're going to go ahead and do with that is we are going to return, we're going to spread out the contents of our result array, and then we're going to push into that the contents of our subarray here. We're going to spread those elements out here. Now, we can go ahead and take this resulting array, and the kata asks for us to sort these elements in ascending order. And we'll do that by doing this. .sort. Whoops. And this is the sorting function that you use if you want to arrange the elements in ascending order. All right, let's go ahead and try this out here. Node flatten warm up, flatten, sort. And we have our flattened and sorted array right here. Let's go ahead and punch this into Codewars to see what this looks like. And we are good on that. Finally, we are checking to see if an array of integers is sorted in either ascending or descending order. All right, let's go ahead and lift this weight here. Const is sorted and how. We have our array right here. All right, what I think we're going to go ahead and try doing here. I think we'll go ahead and keep track of a couple flags here. Let is ascending and is descending. We're going to first set these initially to true here. Now, if actually, I have another idea. Probably a good way to tell if this array is starting in either ascending or descending order is we're going to check the indices of the maximum and minimum values of our array here. And we can do that by doing this. Const min index. We're going to set that equal to array.index index of math.min array. And we'll do the same for the max index here. Array.index of math.max array. So we get the minimum and the maximum indices of, and let me reiterate that. We're going to get the indices of the minimum and the maximum values of our array. And we're going to check to see if one of these is 0. If min index is not 0 and max index is not... Okay, let's go ahead and do this. If min index is equal to 0, then we know we're starting the array in ascending order. Else if min or max index is equal to 0, that means we're starting the array in descending order. Otherwise, we know this array is not sorted. So in here, well, in here we will... Actually, I might not need that else block here. At the end of this, we'll just go ahead and return no. All right, let's go ahead and start with the min index here. So we're going to go ahead and iterate over each number in our array here for const number of array. Or rather, no, we do need to keep track of indices here. For let I equals 0, I is less than, or rather for let I equal 1, I is less than array.length plus I. And if array at index I is greater than or equal to array at index I minus 1, or rather, if array at index I is less than, don't know why we're doing that here. Anyway, if array at index I is less than array at index I minus 1, then we know that this is not sorted in ascending order. We can just go ahead and return no here. Otherwise, if we do reach the end of this loop without this if statement evaluating to true, we know that this list is sorted in ascending order. We return yes, comma, ascending. Now, let's go ahead and handle our max index right here. We're going to do the same thing here as we did with our min index here. So I'm going to copy that and paste that in here. We have, once again, we are starting I at 1, going to the array.length and stepping by 1. This time we want to check to see if array at index I is greater than array at index I minus 1. And if it is, we return no. Otherwise, if we reach the end of this loop, we're going to return yes, descending. Alright, I think this will do here. Let's go ahead and go down to some of these tests here. Let's go ahead and actually punch this into Codewars to see what this looks like here. We're going to go ahead and hit test. And we are good on that. That concludes today's warm-up segment. I will see you in the next kata. To participate in a prize draw, each one gives their first name. Each letter of that first name has a value, which is its rank in the English alphabet. A has rank 1, B has rank 2, and so on. Note that casing is ignored when calculating these ranks. The length of the first name is added to the sum of these ranks, hence a number which we will call sum. An array of random weights is linked to these first names, and each sum is multiplied by its corresponding weight to get what they call a winning number. I'll call your attention to this example right here. Here we have these 6 names right here, and these 6 weights right here. Now, each weight will be associated with the name at the same index of this string once we split that into an array of first names here. Now, the sum of the name Paul right here, which is the 5th entry right here, is the length of that first name, which is 4, plus the ranks of the characters here, 16, 1, 21, and 12. And we get the value 54. Now, the weight of the index of Paul in the weights array is 2. So we multiply that 54 by 2 to get the winning number, which is 108. Now we can sort the first names in descending order of the winning numbers. And when 2 people have the same winning number, we sort those names alphabetically. Now, our goal here is to figure out the winner of this prize draw. And that winner will be the name of that sorted array of winning numbers at the given rank right here. Our kata function will have 3 arguments, which is our first names, our string of comma-separated first names, our array of weights, which will be multiplied to the sums of each of these first names here, and then the rank, which is the index of the resulting array of the winner of our prize draw here. Alright, let's go ahead and lift this weight here, shall we? Now let's handle some edge cases here first. Alright, first if our first name string is empty, first names.empty.length, or rather, first names is equal to a blank string, we can just return no participants. Alright, let's go ahead and split these first names off into an array here. Const first names array, and we'll do first names dot split, and we'll use a comma separator here. Now, if rank is greater than first names array dot length, we will return the error string not enough participants. Alright, what we need to do, we need to get the sums of these names right here. And what we can go ahead and do, we're going to go ahead and set up an array here. We're going to call it scores, actually. And we're going to go ahead and do this. We're going to take our first names array, and we're going to run it through the reduce method here. I'm going to go ahead and shrink this window right here and expand the size of our code editor here. In our predicate function here, we will have our score our result array here, and we will have our name here. And we will also need the index of that name in the array. Now, in the body of this predicate function, what we need to do, we need to take this name, split it off into its individual characters, calculate the rank of those characters, add that to the length of the name, and then multiply it by the weight in our weights array at this index right here. Now, before we move on here, we are going to need the help of a helper function here. We're going to go ahead and call this function getRank. It's going to take a character as its lone argument here. Now, first we need the ASCII code of the lowercase a. Const a code. We're going to take the lowercase a and run that through char code at. And we're going to go ahead and do this. We're going to return char to lowercase char code at minus a code, and we're going to take that result here and add 1 to it to get the rank of the character that we pass in. Now back to our predicate function here. Alright, what we need to do, we're going to go ahead and get the score of this name, and what we're going to do that by taking the name, splitting it off into its individual characters here, and then running that through the reduce method as well. In this predicate function here, we have our, we're going to call it, we're going to have our accumulator here, and we're going to have our character right here. And we're going to set the initial accumulator here to 0. And what we are going to do inside here is we are going to take the accumulator and add to it the rank of the character. And now, on top of this, we are going to need to add the length of our name here. Name.length. Alright, what we should be able to do here is we need to return our accumulator array here. We need to set our accumulator to an empty array here. We're going to spread out what was already in our result here. And we are going to add to it a tuple, actually. And that tuple is going to have 2 elements. The first being the name, and then the score, multiplied by the weight of this name assigned to this name at the given index of our first name's array. And we'll do that by doing this. Weights at index. Oops. Alright. Let's go ahead and console.log this and see what this looks like here. We're going to go ahead and return our scores here. Alright, we're going to test this out a little bit thus far here. We'll go ahead and hit copy here. We're going to do a console.log rank. We're going to paste this here. We're going to paste in our array of weights, 1, 4, 4, 5, 2, 1. And then we are going to pass in rank 4 here. In other words, we want the 4th index of the sorted array of winning numbers here. At base 1, of course. Alright, let's go ahead and test that out here. We're going to do node prize draw. Weight is not defined. It needs to be weights. Let's try that again here. And as you can see, we now have our array of tuples of our first names and their winning numbers here. What we need to do next, we need to sort these tuples in descending order by their winning numbers here. And we're going to use the sort method to do that here. We're going to run .sort A and B. Now, as I go through this sort method here, keep in mind, element number 0 in our tuple is the first name. Element number 1 of our tuples are their winning numbers. Alright, we will first, at the end of the sorting function here, and I have this function body here I'll explain later, we're going to sort these in descending order by their winning numbers. So B at element 1 minus A at element 1. Alright, let's run that through Node again. And we should now have our names sorted in descending order by their winning number. But if you pay attention to the Kata solution here, when two people have the same winning number, they need to be sorted alphabetically by their first names. Alright, let's go ahead and handle that right here. If A at 1 is equal to B at 1, then we need to sort these names into alphabetical order. So what we'll go ahead and do is const A name equals A at 0, not 2 uppercase. And then const B name is equal to A at 1, B at 0, excuse me, not 2 uppercase. And I think it's if A name is less than B name, we return -1. Else, if A name is greater than B name, we return +1. And then else return 0. So, what's going on here? This sort method will sort the elements of an array depending on the return value of the predicate function passed in. If -1, if a number less than 0 is returned, then A will be sorted before B. If anything greater than 1 is returned, then B will be sorted before A. But if 0 is returned, A and B are left alone. Let's go ahead and see what this looks like here. And we do have our names now sorted in alphabetical order. This should work. Let's go ahead and punch this into Codewars to see what this looks like here. Actually, not quite yet. Because we actually need to return the name of our winner here. And that can be done by doing this. Scores at index. Rank -1 at index 0. And that should give us a Paul right here. Let's go ahead and punch this into Codewars to see what this looks like now. We're going to go ahead and hit test this out. We're going to go ahead and hit attempt. And we are good. Now here is a kata that can become quite the doozy if you're not careful here. What tripped me up here was in the sort method when we were sorting the winning numbers of the names here. If two names had the same winning numbers, we had to sort those names in alphabetical order. What we wound up doing was we compared the two name strings using the less than operator and the greater than operator here. Now, when we do that, what JavaScript does internally is compare each character at each index using the lexicographical order here. So A, the lowercase a is less than the lowercase b. The lowercase b is greater than the lowercase a, for instance here. Now, if those characters are the same, we move on to the next character, and the next, and the next, and so on, until it finds two different characters at the same index here. Now, in this kind of solution here, in our sort method here, if it comes out that A name is less than B name, we return -1. And if B name is less than A name, we return +1. Now, what JavaScript's sort method does internally is it sorts the elements of the array based on the return value of the sorting function here. A will be sorted before B if that return value is less than 0. B will be sorted before A if that return value is greater than 0, and A and B will be left alone if that return value is 0. An array is considered circularly sorted if its elements are sorted in ascending order, but its start point is displaced or rotated by a number of steps. Given an array, the goal of this kata is to check to see if that array is circularly sorted. Let's go ahead and give this one a try here. First, let me go ahead and do a little... copy this over here. We're going to do a console.log is circle sorted. We're going to paste this array in here. We're going to make use of this later on here. Alright, first what I think we're going to go ahead and do, we need to check to see if this array is sorted in ascending order. So we're going to go ahead and start by getting the index of the minimum value of this array here. We're going to do const min index. We're going to do array.index of math.min. We're going to spread out the elements of this array here as its arguments. And I think we're going to go ahead and do, we're going to go ahead and fix this array such that the minimum element becomes the first. So I think we'll do this. Const fixed array equals, we're going to do this in an array. We're going to spread out this array.slice at min index, and then array.slice 0 min index minus 1. Alright, let's go ahead and return that fixed array here first to see what that looks like. We're going to do node circularly sorted array, and we should have that is not right. Alright, let's go ahead and get rid of that minus 1 here. Looks like that end is actually exclusive here. Alright. We should now have our fixed array starting at the index of the array's minimum value. What we can go ahead and do from here is we're going to do for let I equals 1. I is less than fixed array.length plus I. And if fixed array at index I is less than fixed array at index I minus 1, then we will know that this array is not in ascending order. We'll return false here. If we reach the end of this loop here without returning false here, then we will know this is a circularly sorted array. We will return true. Alright, let's go ahead and test this out here. That gives us true. How about one of the invalid ones here? 8, 7, 6, 5, 4, 3. That should give us false. Yep. How about 6, 7, 4, and 8? That should give us false as well. Yep. How about one of the true ones here? 1, 2, 3, 4, 1. Wait a minute. Yeah, how about an instance where we have more than one minimum value? Okay, what we'll do is, instead of index of, we'll do last index of. That way we get to the element of the we'll do the last index of method here instead. So we'll get the index of the last occurrence of that minimum value here. And that should give us true right here. Alright, how about that other one here? 2, 3, 4, 5, 0, 1. That should give us true right here. Alright, let's go ahead and punch this into Codewars and see what this looks like. We're going to run the test here. And well, we have a problem here. What's going on? Edge cases. Alright, let's go ahead and log that fixed array here. Console.log fixed array. We're going to go ahead and hit attempt again. See where we are going wrong.
That is in descending order. Yeah, this is looks like ascending order here. 40, 46, 45, 39, 27, 25, 20, 16, 18, 20, 27, 30. Minus 99. Oh, wait a minute. Okay, it's also longer than min index as well. Six.
Alright, let's go ahead and grab this array right here. And put it in our place in our local solution right here. I'm gonna hit copy. I'm gonna paste this in here. We do get false here, but it's supposed to return true. I think I know why. It's because these, I think it's because of these consecutive minus 99s here. So let's go ahead and get the first index of that too. And we're gonna set this equal to index of. We're gonna do another index here called last min index equals array dot last index of math dot min dot array. And then what we'll go ahead and do here, instead of consts, we're gonna make this a let here. We're going to go ahead and comment this out here. And we're going to do a let fixed array. I'm going to set it equal to null initially. If min index plus 1 is equal to last min index, then what I think we'll go ahead and do, we're going to do fixed array equals dot 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 array dot slice min index dot 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 array dot slice 0 min index. Else fixed array equals dot 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 array dot slice last min index dot 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 array dot slice 0 last min index. See what that looks like. Now it returns true. Now what if we had instances where let's go ahead and try punching this into Codewars to see what this looks like here. Hit copy, paste. We're on the test. Let's try hitting attempt now. And we are good. Now here's another kata that'll slip you up if you're not careful here. What slipped me up here is what I did to unrotate the circularly sorted array was to slice the array at the index of the minimum value of that array and place that at the beginning of the array and the array before that minimum value afterwards. What I failed to account for was, however, when there were instances where the minimum value of that array was occurring a consecutive multiple number of times, like for example the minus 99 at the 2 consecutive spots in that array where we were screwing up at. What I did to account for that was I went ahead and got to the index of that value and the last index of that value in the array. And I checked to see if they were occurring consecutively, if index plus 1 equals last index, for instance. If it was, I went ahead and did the slice starting at that first index. Otherwise, I would do the slice at the last index. Another thing that I didn't know would cause any more failed tests was if that minimum number was occurring more than 2 consecutive times. As it turned out in this case, I did not need to account for that. I will be thinking about that at a future date though. Given an array of numbers, the goal of this kata is to calculate the ranks of those numbers, 1 for largest, 2 for second largest, and so on, and then return an array of the ranks of those numbers. Alright, let's go ahead and give this a try here. I've got a couple examples here, right here. Alright, this should return 2, 4, 3, 1, because 10 is the largest, 9 is the second largest, 6 is the third largest, and then 3 is the fourth largest. And in this array should return 2, 2, 2, 2, 1, 7, because 5 is the largest. We have a 5-way tie for second place here with these 3s here. And then 1 is the third largest. So this would be in 7th place because of this 5-way tie here. Alright, let's go ahead and give this one a try here. How about we try doing a lookup table here? Alright. That might be a good idea. Const lookup table. We're going to set that equal to an empty object for now. And what we'll go ahead and do, we're going to go ahead and iterate through our scores here. Scores.length, or rather, we're going to keep track of a current rank here. Keep track of. And what we'll go ahead and do is we want to go ahead and do for let I equals 0. I is less than scores.length plus I. We're going to iterate through each of our scores here. We probably will need to sort our scores here first. We're going to go ahead and do const sorted scores equals scores.sort A, B. We're going to sort this in ascending order. We're going to do for const score of sorted scores. Actually, this needs to be in descending order. And what we'll go ahead and do is if our lookup table doesn't have an entry for the current rank, then we'll go ahead and add that to current rank equals score. Let's go ahead and return that for now. Look up table. Let's run this new node and see what that looks like here. That's not what we were expecting here. Alright, we need to go ahead and increment our current rank here. We're going to go ahead and console.log our sorted scores. All right, I'm going to do an else case here. Or rather, at current rank. All right, we do an else case here. If lookup table at current rank -1 is equal to our score, is not equal to our score, then we'll do current I think what we'll do, if lookup table at current rank -1 is not equal to our score, we'll do current rank ++. And I don't think that is it though. No, we do need that current rank ++ here.
Now we need to get rid of these here. I think what we'll do.
Yeah, if our current rank is 1. We'll do this anyway here. Now, else if lookup table at the index of current, the key rather, of current rank -1 is not equal to our, oh, okay, what we can do here, if current rank is equal to 1, or lookup table at current rank -1 is not equal to our score.
Now. Okay, what we'll go ahead and do here. Current rank is 1, or yeah, we'll go ahead and get rid of this for now here.
I have a new idea here. Let previous score was null. And we're going to go ahead and set that previous score here. Now, there are likely will be negative. Now, I can probably expect there to be negative numbers here, so if previous score is null or score is not equal to previous score, and then we'll go ahead and add that score and the current rank to the rank lookup table here. And yep, and we do have the correct lookup table here. Alright, now what we need to do, we need to make up an array of the ranks of these scores here.
Now, how do we go about that? What we could do is
we'll try this. Return scores, not reduce. Ranks and score. We'll set the initial accumulator to an empty array here. Now I need to figure out the key storing the score in our lookup table. Let me play around here. I will be right back. Give me a few moments. Okay, here's what I think we're going to go ahead and do. We're going to do a const rank. We're going to do object.keys lookup table. And then we're going to go ahead and do a call to find here. In this predicate function, we're going to have our rank here, our lookup rank here. And what we're going to go ahead and do, lookup table and to look up rank is equal to our score. And then we should be able to push that into our array here. Alright, let's see what this looks like here. 1, 2, 2, 2, 2, 2, 7. 1, 2, 3, 4. Now this needs to be parsed into an integer here. Parse int. Whoops, parse int. And I think we've got it here. 5, 3, 3, 3, 3, 1, 1, 2, 2, 2, 2, 2, 7. Alright, I think I like where this is going. Let's punch this into Codewars and see what this looks like here. Copy. Paste. There does not seem to be any sample tests here, so let's just go ahead and hit attempt. And something has gone wrong. Now our scores are not sorted. At least they shouldn't be. Console.log scores. And wait a minute, yet they are. Okay, what we'll do here, we're going to need to slice this array. I have, you know what, I have no idea how it happened, but sort was modifying the scores array before assigning it to sorted scores right here. That, I think, was what was going wrong here. This should now be right. Let's go ahead and punch this into Codewars to see what this looks like. And we are good. Here is the better code solution of the day. Pay mind to the code snippet you see to my left here. First, we need to create a new copy of the array, and then we sort that copied array. This caused us quite a bit of frustration in our Kata solution here, because not only does sort return the sorted array, it actually modifies the array on which sort is being called. That caused us quite a bit of frustration before we realized that we needed to create a new copy of that array. Next, we take the array that we passed in, and we run it through the map method, and for each element, we map it to the index of that number in our sorted array, and then we add 1 to that index. In so doing, we get an array of the ranks of the numbers that we pass in. Given 2 strings, the goal of this kata is to sort the characters of the first string by the order of the characters in the second. Any character in the first string that does not appear in the second will be sorted to the end of the string in their original order. Alright, let's go ahead and give this one a try here. Alright. We're going to go ahead and do const first chars. We're going to get the characters of the first string. And we're going to do second chars. And we're going to get the characters of the second. I don't think we need to do that, though, do we? I don't think so. Anyway, what we'll go ahead and do, we need to return the first chars.sort. In our sorting function, we have our A and B. Now, what we need to do, we need to get the index of characters A and B in the second string. Const AI equals second.index of A, and then const BI equals second.index of B. Now, if AI is not equal to -1 and BI is not equal to -1, then we know that both characters are in the second string. And we need to go ahead and sort that out in ascending order of their index. So we'll do return AI minus BI. Now, couple else if cases here. Else if AI is equal to -1, else if BI is equal to -1, I think what we do, BI is equal to -1, putting BI first. I think we return 1 here, and -1 here. Let's go ahead and first return 0 here. Let's go ahead and test this out here. Console.log. Sort string. We have our foos and of. Let's test this out here. Node string of sorts. And we have the characters O, O, F, and S. How about our banana here? B-A-N-A-N-A, A-B-N. A-A-A-B-N-N. It's actually what we were looking for here. String, and then string backwards. G-N-I-R-T-S. G-N-I-R-T-S. Yeah, that's actually right. Let's go ahead and have a look at some of our other tests here. Yeah. Okay, let's go ahead and punch this into Codewars to see what this looks like here. Run these tests. I don't like the look of that because we need to join those characters together here. Alright, let's try that now. And we are good. Not much to say about this one. However, I was initially a little concerned about the bit of the Kata solution where I had to sort characters in the first string, not present in the second string, to the end of the result string in their original order. What I went ahead and did was, if in the sorting function the character A is not present, I would go ahead and sort that character to the end of the result string. If character B was not present, I would go ahead and sort character B to the end of the array. And if neither character was present in the second string, I would go ahead and return 0 to leave the original ordering alone. As it turned out, with all the other sorting that I did in this sorting function here, that was enough to give us the correct strings we need to solve this kata. Here we are given a two-dimensional array representation of a glass of mixed liquids. The goal of this kata is to sort that array such that the liquids appear in the glass based on their density. Lower densities float to the top. The width of the glass will not change from top to bottom. I'll call your attention to this chart right here, which shows our densities here. Here we have honey, water, alcohol, and oil. And each element of these subarrays here will be letters corresponding to these liquids right here. And these are values tied to these liquids right here. The goal is to sort these liquid elements out such that the liquids of the lesser densities float to the top of the proverbial glass here. The glass representation may be larger or smaller. If a liquid doesn't fill a row, it floats to the top and to the left. Alright, let's go ahead and give this one a try here. Train. I'm going to have a look at some of these tests here. Alright. Okay, what I think we'll go ahead and do. Alright, we're going to do const separate liquids. We're going to have our glass here. That's going to be our two-dimensional array. We're going to need to use a lookup table here for our densities. Constant density. And we're going to do H for honey. We're going to set that to 1.36. W for water. We'll set that to 1.00. A for alcohol. 0.87. And then O for oil. Set that to 0.80 here. Alright, well, we'll go ahead and do that. First, I think I see us flattening this array of subarrays here. So what we'll go ahead and do, we're gonna do const flatten. We're gonna do glass.reduce array subarray. We're gonna set that initial accumulator to an empty array here. And what this will do, this will flatten our glass subarrays here. Array subarray. Now, what we need to do, we're gonna need to sort these liquids here in order of their density, and we're gonna be doing this in ascending order. Now sort A, B, A minus B. Alright, let's go ahead and return that. And we're going to go ahead and do a little console.log here. Let me go ahead and grab this one right here. I think that was the one from our example here. Yep. I'm going to copy this, do a console.log. Alright, let's go ahead and see what that looks like. Whoops. No, don't drink the water. Yeah, okay. I got that all wrong here. Density at A minus density at B. And we should have the elements of our flattened array sorted in ascending order. Alright, now what we need to do is unflatten this array here. Now, what I think we're going to need to do it's likely no guarantee that each of the subarrays of our glass are going to be of the same length. What I think we'll go ahead and do, first and foremost, let's go ahead and go with the naive approach at first. And we'll do that by doing this. Go ahead and calculate the width of the glass here. Const glass width. Let's set that equal to, I don't know, glass at index 0.length. Then what we'll go ahead and do, we're going to go ahead and glass sliced equals glass.slice. Make a new copy of this array here. And I think we'll do this. For let I equals 0, I is less than flattened.length plus I. I think we'll go ahead and do glass sliced and index I divided by index math.floor I divided by glass width at index I modulo glass width equals flattened at index I. And then we'll go ahead and try returning glass sliced here. And we should have, and that looks like our array here. That looks like our sorted glass here. Now, I know this is going to produce some failed tests, but let's go ahead and punch this into Codewars to see what this looks like here. And we'll handle the failed test as proper. And sure enough, should be able to handle empty array. Yeah. Cannot read property length of undefined. If glass.length is equal to 0, then we return an empty array up here. So we can handle that edge case right here. Alright, let's try that again. Alright, these initial tests pass here. I know we're probably going to get some failed tests when we hit attempt. Let's see what those are. Actually, there are no failed tests. We're good. Now, whenever I'm solving katas here on Versus Codewars, I tend to run into a lot of nasty surprises when it comes time to submit my kata solutions for testing. However, sometimes I run into the occasional pleasant surprise here. Here, I was expecting to handle cases where the rows in our sorted glass, a row in our sorted glass was less in length than the width of the glass itself. According to the kata instructions here, if a liquid doesn't fill a row, then it floats to the top and to the left. I was expecting to handle cases like that for some of the tests. As it turns out, quite surprisingly and quite pleasantly so, I did not have to do that here. I wonder why. And that is going to do it for today's episode of Versus Codewars. If you like this video or you learned something new, drop a like and subscribe to my channel to see me take on more coding challenges on Codewars. As always, if you think there is anything I can do to improve on my code for the better, feel free to drop a suggestion in the comments section below. Also, if you are a kata author on Codewars and you would like to share your authored katas with me, feel free to drop links to those katas in the comments section below, and you might see me try to solve them on a future episode of Versus Codewars. I hope you have a wonderful day, and I will see you on the next episode of Versus Codewars.